These are the examples for Lesson 9. This is example 19.1. Compute the allowable tensile load for the single shear lap joint shown in the figure. The plates are ASTM A36 and the high strength bolts are 3/4 inch in diameter, A325X in standard holes. Okay, so given a single shear lap joint shown, the plates are ASTM A36. We have a 3/4 inch diameter bolt, and that's A325-X. That's high strength bolts. N is 1. That's the number of shear planes. The large capital N is the bolts, number of bolts. In this case, it's 6, as shown here. And find the allowable tensile load. Now, to do that, we're going to do 4 checks. The first check we're going to do is we're going to check the shear in the bolts. And we're going to use equation 19.2 to do that. So the load is N, which is the number of shear planes, times AB, which is the area of the bolts, times this FV, which is the bolt allowable shear stress. We get that from table 19.1. And then N, which is 6 bolts. Okay, so when we do that, we get 90.1. Okay, so then we're going to check the bearing stress. So we're going to use equation 19.3. That's D, which is the D is the diameter of bolt times the thickness T of the plate. That's the 3/8 inch times this FP, which is 87 KSI. Again, that's from table 19.2. Bear with me a second here. Let me find you table 19.2. And there you go. So FP is the allowable bearing stress of 87 KSI. So that's where we found that one. Times N. We multiply those out and we get the bearing stress load is 147 K. So far we're limited by the shear stress in the bolts. Now we're going to check the gross area. That's equation 19.4. The load in the gross equals the area, gross area times F sub T. That's the tensile stress. F sub T equals 21.6 KSI. And I'll show you where that's at again. That's right here. That's just 21.6. Okay, so when we're doing a test for the gross tensile strength, we're going to use this value right here for gross. When we're doing it for the net, we're going to use this value for the net. One more thing I want to show you while I'm here is this one right here. This is 19.1, table 19.1, and it talks about the A325. Now the difference between, let me show you the problem first of all. Okay, so that's this equation right up in here. So the allowable bolt shear stress. So this problem is given A325X, and it's asking you what the allowable shear stress is. So we come over here, and X means that's this one right here. X means this 34, which is threads are excluded from the shear plane. Okay, so if you notice, how this is handled is that when we have threads in the shear plane, we're using a lower shear stress for a lower allowable shear stress for the bolt. When we're excluding the threads from the shear plane, we're using a higher allowable stress. So that's how you interpret this. Okay, so that's the gross area. And then the net area. Okay, so I spent some time with this one right here. So the net area is the gross area minus the projected areas of the holes. Now your textbook calls this projected area of the holes DH times T times N. Now DH is the width of the hole. So what we've done here is we've added an 1/8 inch to that diameter so that the bolt will fit through the hole. So the DH is actually 875, which is allowing us some clearance for the on each side of the bolt. So then we calculate our net area. In this case, it's 3.52 inches. Then our load based on the tensile load based on the net area, we use a different strength based on the net area out of 19.2, and we get 102K. So if I was to summarize the 4 checks we've got here, bolt shear was 90K, bearing stress is 147K, shear stress in the gross area is 97.2K, and then shear, I'm sorry, these are tensile failures here. In the net area is 102K. So now that we have this, we have all 4 of them, we know that our maximum load is based on the bolt shear, and the maximum load is going to be this 90.1K. Okay, I'm going to end this one right here. Thank you.